Today's guest is Ken Gray. He's the co-founder and chief performance officer at Dig Robotics. All right, Ken, thank you for coming on the show.
It is an honor to be here, truly. Thank you.
Awesome. I mean, you have, a lot of background in construction and technology and all that stuff, but you mentioned briefly before we went on the air, you spent some time in Japan. So I'm curious, why did you go?
Um, my wife and I always talked about if we had the opportunity to go on the great family adventure, that we would just go. And it was 1990, and my engineering supervisor tapped on his glass. They were in these glass cages, and we were out in this sea of desks, and tapped on his window and motioned for me to come in. And as I walked through the door, he threw something at me and I caught it. And it was an orange Japanese English dictionary. And he said, Ken, would you like to go to Japan? I said, sure. When do you want me to be there? And he said, no. He said, not, I don't want you to go there for a week or so. I want you to go there indefinitely. And I said, sure, we'll go. Let's go. And he said, do you need to go home and discuss this with your wife? And I said, no, I will, but I don't have to. And he said, I'd like you to go home and discuss it with your wife. And when I got home, she said, why are you asking me this? We've already talked about this. So
Which is good though, because on the surface, if I was your manager thinking,
right.
maybe you want to let this settle, all right? I think it was
Right.
already kind of the plan, so the timing was very good. But
Yeah, it was the beginning of the great gray family adventure. It really was. Our children were kindergarten, I'm sorry, preschool, so Yochien age, my daughter, and first grade for my son. So they went to elementary school in Japan. Then they moved us to Belgium, where they went to middle school, and then back to Peoria. I worked for Caterpillar for decades. So you go to Peoria. I went to Peoria for a cup of coffee. And then the Chicago area is where they went to high school. So if you ask them where they're from, they give usually you get a blank stare and they try to figure out what answer would appeal to the questioner the most. So
it's
we had a great, we would, it was fun. I think Japan is one of the most difficult places to work in the
mm,
world. One of the great places to live in the world.
great.
I love living there, love being there.
Talk to me
Kyo,
about you coming in as an outsider. What were the challenges that you saw?
well, you are an outside there. Hey, one of the things that we were fond of saying was, remember that your Japanese teammates did not choose you.
Mm,
Because I was part of what was then the most successful joint venture between a Japanese and a U.S. company. It was Sheen Caterpillar Mitsubishi was the excavator originally, the excavator joint venture. Lived in Kobe, Japan, which is from at that point in time was a lot of Westerners. And there were probably 800,000 Westerners in a city of 2 million. That's a lot. It was a lot in Japan at that point in time. So we wanted to be careful that, um, how do I say this? We wanted to be careful to acknowledge that it's our temporary home, even if we were going to be there long term. It's their culture. We talked about studying the language a little bit. I think the language and art are the window into people's soul.
yeah.
And so studying the Japanese language, um, uh, and studying their art, I think was really important to us to understand them. And then food is probably next. I had a Kobayashi Jicho, my supervisor, would try very hard to find something in Japan that I would not eat, and I never ever gave him the satisfaction of seeing that I did not like it.
What what were some of the things that he put in front of you that you really had to put on your game face to eat?
Oh man, he put natto in front of my face, and buddy,
Fermented bean.
I really had to. I don't know. I don't think I fooled him on that one. I like to think I did, but wow, was that tough for a Westerner to the first time and really enjoy. But really, Japanese cuisine is very local, remarkably local. And you could go to the Japanese seaside and find things that you could never find in the Kansai or in Tokyo. And I was always really, that was always a lot of fun to me. My wife loves tonkatsu. And it's like if people don't know what that is, it's a pork loin that's beaten to a pulp to be tender and then breaded and deep fried and sliced very neatly. And then the presentations are really cool too with the white cabbage and then there's a little mortar and pestle typically where you're grinding the sesame seeds and it's just it's an event for us to go to a great tonkatsu restaurant. But it's also like Midwestern comfort food, Midwestern U.S. comfort food. It's like fried pork chops. It's kind of a familiar flavor with an amazing presentation. And anyway, but
Yeah.
we loved it. We had so much fun to be in
Yeah,
there.
which is
Really.
it's interesting because like I have a bit of a perspective because I come from a Japanese background. I was born there for a bit, gone back there a ton, but I couldn't survive living there. But my sister loves it,
Uh-huh.
has lived there for a very long time, and would never come back. So,
Right.
but I know why I can't do it. I know why she can't do it, and I think the effort that you put in, like
Yeah.
I mean, English is a second language in Japan, right? Everyone wants
Right.
to learn English, so there's
Right.
there's that part that helps, but the effort that you put in, I think went a long way
Yeah.
to showing
It
that
did.
you respected the process.
It did. Yeah, I mean, you have to know, they have to know that you're not here today, gone tomorrow. And there's a cultural element of that for sure, but they need to know that you have, and I think this stands up in any culture, that they need to know that you're standing with them, and that you're going to be there for a long time
Yeah.
with
Well,
them.
construction is that way too, right?
It is.
Long-term relationships. There's a lot of,
It is.
technology things that come into the construction industry and they're gone. They're gone in a few years, right?
Oh, they are. Yeah. Or they, I talk about, Maslow's hammer quite often, this idea that if you have a hammer, every problem is going to look like a nail. And we very often have technologies that we like, that we know, and we try to hammer them to fit into a construction problem. Um, that might not even exist, you know, and so they're here today, gone tomorrow. And I think many the most successful contractors are the ones that have an area of expertise, right? They know their business extremely well. They know margins are tight, and they have they're not reticent necessarily to new things, but they're not willing to risk they're not willing to bet their business on a new technology and and underbid a job and then lose their business because of it. I mean, they're careful, and they
Yeah,
should be.
sure. When you went to Japan for Caterpillar, were you part of the innovation side, or what was that capacity you went over there for?
I was a very young design engineer. I was
Okay.
29 when I went. And I was a structural, welded structures, vibrations, that kind of thing.
Yeah.
And my role was to improve the technical capabilities of the very capable already design team that was there. It was part of, most of them were Mitsubishi Heavy Industries guys that were they were pretty good. I mean, they were pretty good. And Caterpillar was presumptuous enough that they could put me over there and I could make them better. I think we did, but I think we got better by working together. More than anything else. And it's like all things. You learn to listen more than you talk. That's hard for me because I famously love the sound of my own voice. And you listen to what they want, listen to what they need, and see if you can satisfy that. And when you demonstrate your value by solving a small problem, you're asked to solve a little bit bigger problem and a little bit bigger problem after that. And some point you become, I mean, it was a great, I went back, I went there twice. So I lived there as a design engineer the first time, and then I went back as a director of the company the second time. So it was you can never go home, you can never quite go home. But in the middle, like you, I traveled continuously to Japan, and I remember I loved this. Going to a meeting, and the the Westerners would kind of confer on one side of the conference room, and our Japanese colleagues would confer on the other side of the conference room. And they were having a conversation, and I was standing near the Japanese group, and I responded to them in Japanese. And one of my dear friends looked at me and looked at the group, and he said, "Oh, we have to be really careful here because Ken-san speaks Japanese." I thought that was just, and they weren't saying anything to try to hide anything from us. They were just having a normal conversation, and they forgot that, at some level at that point, I could still engage. So I just
Sure,
thought that was
sure.
really interesting. I was gonna, before I forget it, I think the greatest compliment I ever received from in business was from a taxi driver in Japan.
Really.
I had moved away. I had moved to, we had moved away on our next assignment, and I was back visiting on business, um, and landed in Kansai Airport. And one of the drivers who I happened to know was the taxi that I was going to get into. And I told him I wanted to go to the hotel I wanted to go to, and he said, why don't you want to go home? We should go to Paramount Roko, which is where I lived in Rokomichi in Kobe. And I said, well, Zannen, this guy, I had to move home. I moved home. And he said, you should retire here. And this is all, of course, in language. You should retire here. He said, you understand Japanese politics, baseball, and sumo. You love our food. You're really comfortable here. You should come back and retire here. And I genuinely thought, I still believe that is the greatest compliment that anyone could ever give. That's great. That was just
That's
great.
awesome. That's great. Before we go on to some of the newer stuff you're doing, I mean, what sort of problems were you trying to solve? I mean, obviously innovation, there's risk adversity and stuff. What sort of challenges or problems that Caterpillar was trying to solve, and what was on your desk?
Well, the whole idea of the joint venture was that Caterpillar needed to get into the hydraulic excavator market that Mitsubishi arguably invented. I mean, there's some other companies that can lay claim to inventing it, but I think Mitsubishi Heavy Industries can lay a legitimate claim to having the first hydraulic excavator. And Cat didn't have access to the Japanese market at all at that point in time for excavators. In fact, the former version of the joint venture excluded excavators from the joint venture. So the Sheen new joint venture between the two companies brought excavators into the fold, and it also gave Mitsubishi access to the Caterpillar dealer network worldwide. So the whole idea was to get into that excavator business. So the kinds of problems that were on my desk then were um, taking a utility machine that excavators were at that point in time to a much more high production, high efficiency machine that they have become. And the problems associated with that. So I remember one problem that we were having um, axial piston pump failures on the 20-ton excavator. And the reason that we were having them is because we were trying to drive more horsepower through those pumps than they were really intended to have. So the job was to, fix it. The pump is failing. It was a structural failure. Let's model it, see if we can understand what's happening, what's the root cause of the failure, and what are the potential design improvements that we can make to get out of that problem. It's a very typical problem that we had.
I mean, it sounds like a problem that, can really affects the company. I mean, when those things happen, I mean, is it everyone all hands on deck 24/7, or is it one of those kind of it's been a nagging thing that, hey, through the, it works enough of the time that it's good and it's within spec, but it's bleeding our P&L. Like what scale was
Oh,
that problem?
it was bleeding the P&L enough. I'm a design engineer. There are 7 layers of management between me and the vice president who called me every day.
That's a
Okay.
basically
I was terrified. I mean, I was literally, quite literally terrified
it's like,
of what
Ken, why
that
are you
next call.
sleeping?
What are you doing? Why aren't you in the office right now? So, and this is the kind of problem where you can project the hour accumulation, the average hour accumulation when it's going to fail. So, I know I've got a little bit of time, but I can tell you pretty much by month based on our accumulation when these things are going to fail, when they're going to fail. And it was, problem like that, that's one of the highest 20-ton excavators, the highest volume machine on the planet. And if you're failing a pump, that means you're throwing shrapnel into the system typically, and you've got a major clean out to do. So, we were on it. It was all hands on deck to get this one fixed, and we got it. And we found the root cause fairly quickly, and solved the problem fairly quickly too. But it was. I have PTSD from those phone calls. I just have to
And
say.
I'm just trying to imagine the communication and around that, right? You solve it, you're like, well, how do we roll this out, right? Like,
Yeah.
how's it gonna work? What did that look like?
I didn't experience. I was such a low level designing. I was only worried about I got to fix this design.
Yeah.
Later on in my career, when I was running one of the units, was running the large excavator unit. We had a similar pump failure type of problem, a very similar failure. Um, but we had far better information. So it was a relatively new machine, and I had GPS data on every machine on planet Earth, and the volumes weren't as high. And one Monday morning, when we ran our quality meeting, we noticed that 2 of the machines were down. Well, these are production machines, large excavators, 75-ton excavators. Why are they down? I want to know why they're down. Get to the dealer. I want to know why they're down. And it turned out they had each of them on different continents had a pump failure. So my PTSD came right back.
Oh,
And we started uh, analyzing, and we had our accumulation on every machine in the world
but
at that
then you
point.
were the person on the phone calling
Then
the.
I was the person saying, "What are we going to do to fix this problem?" And it turned out that we had a miscommunication around specifications that were required that caused the problem. So we knew virtually every pump in the world was going to fail. Everyone was going to fail.
Oh,
We were going to have a 100% failure rate. And so what we did, we were able to solve the problem. We found that, we knew the root cause of the problem. We were able to solve the problem. The way we solved that commercially was what I think of as a seed program,
mhm.
where we put new pumps in the field, and brought the old pumps home. So, it was a combination of having to put a rental machine, if you will, in place, a machine that I owned or a dealer owned, and I paid the dealer to put it in place. Put a machine in place so that the customer loses zero productivity, get the machine offline before it fails, because if you get the pumps replaced before failure, well, it's just, oh my gosh, I mean, it's an order of magnitude less costly for
Yes.
everybody.
Yes.
And then down the road, the machine will be cleaner, and you can anticipate it being more reliable through the life of the machine if you can
Yeah.
get to it early. So that was our basic approach. We just went, took the machines out of the field, with rental units in their place, of course, that I paid for, that my business unit paid for, my business paid for, uh, did the swap, did the repairs. There were some system changes that we decided to make more than just the pump. So it wasn't just,
Mhm.
let's get the pumps out. There was a hydraulic hammer problem where we were too close to the natural frequency of the hydraulic system. So we actually had to change the natural frequency of the hydraulic system itself. So it was a little bit more complicated than just the pump. So we made those changes, and on every machine that we brought back in. And I was at the Daytona 500 that year, sitting back enjoying the race, and someone tapped on my shoulder and said he wanted to introduce a customer to me that had two of those machines, and he wanted to thank me for taking them out of the field and
Yes.
replacing those pumps before the machines came down. But the only way we were able to do that is because we had the analytics that said, you know, this is the, we actually knew the order of the machines that we had to go get. You know,
Yeah.
we knew how old they were, we knew how many hours they had, we knew how many
Wow.
hours they were accumulating. So we were able to prioritize the machines in order, to avoid failures. And we didn't get them all. I mean, we made a couple of them, were outside of the bell curve of anticipated performance, but by and large, we got virtually everybody fixed, replaced before failure.
Wonderful. Now, what sort of problems are you trying to solve now?
You know, I retired from CAD in 2015. I was honored to be their first global director of innovation, and I had a wonderful career. And I wanted to go do something different. Because man, because I'd done, I mean, I loved it. I'd do my Caterpillar career over immediately. I just, without hesitation, I'd do it again. We had some family projects that we wanted to do, but my mentor, who some of your listeners probably know, Ed Rapp, says that I have failed at retirement because I just can't not do something. Well, my dad argued that one of the secrets to longevity is meaningful work. And I think he's right. I don't think excessive work is healthy, but meaningful work is healthy. And what we're trying to do now, we've created this little startup called Dig Robotics that we were just honored, by the way. It doesn't bring us customers or investors, but CEMEX just ranked us as one of the top 50 construction technology startups for 2025, which is just an incredible honor for us.
Right.
Um, we're focusing in on improving the operator performance in, imagine this, hydraulic excavators first and foremost.
I thought you already had PTSD.
I know it comes as a shock to you, but that's what I want to, that's what we're starting on. So, Volvo Construction Equipment did a study a number of years ago about the variability in performance among guys that move dirt, among excavator drivers. And they studied, I believe, 80, if I remember right, the population was about 80. And they found that in terms of volume per hour, productivity or tons per hour, that the variability among experienced and expert operators is 300%. Think about that. 3x from
Wow.
that's the kind of variability you get performance. From an efficiency standpoint, which is work per unit of fuel, so say it's tons per gallon or tons per liter or something that like that, the variability is 1.5x. So I can't imagine being a site manager with a schedule and that I've got to keep. And the variability among my most experienced operators in terms of performance, what they're going to deliver me today, the volume they're going to move today can vary by as much as 3x. That to me is crazy.
Hmm.
And then think about being on cost. Well, the variation among them is only 1.5. It's only 150%. What's the problem? So I can't tell you that I'm going to be on my timeline, and I can't tell you if I'm going to be on cost because there's so much variation. That's just staggering to me. Now, if you've got rental machines in your fleet that you're moving dirt with, if you put infrequent and novice operators into the equation, then that performance delta is 7x. I mean, that's like having a bunch of Ken Grays out there operating equipment. Quite frankly, that's you cannot get you're not going to make money doing that. And the efficiency delta is 3x. So here's what what we decided to do. Robotics is in our name, but we don't want to automate at this point in construction. Customers are not asking us to automate. Regulators are not telling us it's time to automate. But what we can do with the technology that's become available in the last 5 years, 10 years, we can make operators a lot better than they've ever been before. We can give really highly experienced operators great insight. We can bring novice operators up to speed really fast. We can move that mean of performance and efficiency to the right. That is, we can push everybody in the right direction. And really importantly, too, we can squeeze that standard deviation down so that the site manager can maybe sleep at night, that that I might be on schedule. So Dig is the intersection of three technologies, or two technologies that everybody's familiar with, and one that maybe fewer are familiar with. And I'll start with that one. That's the intersection of kinematics, which is just the study of motion. And what we can do from an engineering point of view is we can calculate the ideal cut for each and every one of the thousands of scoops that are required in an excavation between the green field or the brown field and the near net shape. So for every one of those thousands of cuts based on the topography of the site and the shape of the bucket and the geometry of the machine, we can tell the operator exactly the path that he or she should be on through each cut. But that's a theoretical calculation, right? And we know that shit happens out there, things happen out there, right? So we're also looking at its 3D imagery. So our first, we're pre-production right now. We're running beta tests right now more than anything else. So we have a 3D scanner, it's LiDAR in this case, that is watching what's happening in the bucket at all times. It's watching the load. So it is, and the computer is determining whether or not that path that we have recommended that the operator be on and the path that the operator is taking, is it really ideal? Is it too deep or is it too shallow? Should the bucket be curled or should it be open? Is it full enough that we can extract the load and keep everything that we've loaded, or do we need to stay there longer? That's what the 3D imagery does. And then the third element, so it's kinematics or motion planning is what what our engineers like to call it. And then it's 3D imagery. And then the third aspect of it is machine learning or AI. We probably should put AI in the name of our company just because it's such a buzzword. But really what it is it's a fairly simple machine learning algorithm that is learning from each scoop. So it's learning how dense the material is. It's learning whether there's high moisture content or not. It's learning how granular it is. So, probably that first scoop might not be great, but the second scoop will be informed by the first one. The third scoop will be informed by the first two scoops, and so on and so on. And we're calculating millions of data points as we go forward, and we're able to take someone like me and give me continuous feedback about where my bucket is. Too shallow,
Yeah.
too deep, open, close, that sort of thing. And then for a more experienced operator who would be driven insane by that, we can provide trending information.
Yeah.
You need to be deeper. And then we can
You're
give
like on the
site,
top end of the productivity scale.
right.
You can
You don't,
shut that off.
you can shut it off and we'll just tell you how you're trending. And then we can give site managers a lot of information too. In fact, we're about to send a report to, we have one of our beta tests in Texas, We're going to show them. We're going to show them how they run every day, how they're running every day, the loads that they get in each stroke, how close they are to optimal. So we're able to give them that kind of feedback, and we've been able to get some big improvement. We're able to get 30% improvement out of, really that kind of guidance without having to without I've made the mistake in my career before of trying to take control away from a good operator. They don't like it. But if you're advising them and their only competition is themselves, your only competition is you. Do you want to learn from these insights? And most of them do. I think, well-paid excavator drivers are like fighter pilots. Their hand-to-eye coordination is incredible. And they are good because they've tried to be good. They've worked at being good, and they like being the best. So, I mean, if the culture of the company is like that, actually, we
Yeah,
have one customer who wants to post on the bulletin board the performance of his operators at the end of the day, because he
there you
wants
go.
he wants them to have. I think he wants. It's like a skins game playing golf. I think they're after creating that kind of competition among them, which I think is kind of
Nice.
fun. I think that's kind of fun. Anyway,
Very
that's what
cool.
we're doing. It's really early on. Um, it's really exhilarating though. I mean, someone asked me what's the big difference between the big company and the startup. And if you ask somebody at Caterpillar what time it is, they're going to look at a planning calendar. You know, if you ask somebody at a startup or young company what time it is, assuming they're wearing one, they'll look at their watch. But I will tell you that founders know their death date, the day the company will cease to exist without more revenue or investment. Every one of them knows their death day,
The
which
runway.
is,
There you go.
yeah, they know the runway. So that's a big difference, and we're trying to prove, we have to prove our value every day. I'm sure big companies, at Cat, we felt the same way, had to prove our value every day. But if you don't prove your value early on as a young company, you're just not going to make it.